Today is to come up with a few ways that we can experience resonance with sound in the real world. So the Tacoma Narrows Bridge was an example of resonance, but not necessarily resonance with sound. Can you think of anything where we're experiencing resonance with sound in the real world? Any guesses? I'm sure you've experienced some of this in your life. That's okay. So, yes?
Oh, I was just going to say, this might be wrong, but like when you like have like a big speaker and like you can touch it and like feel it moving.
Sure. If you can feel that moving, it is resonating at a particular frequency. Absolutely. That's one example. If you go to the dollar store, you can find another example of this. Maybe you can find these at Party City too. Right? Yeah, I think they call them a sound tube. I'm going to try and do this back here. I'd usually give myself more space, but I want the folks at home to be able to see this. So basically with a sound tube, all you do is you want to get wind going through the tube at a certain rate. So if you swing it just right, yeah. So you can hear that frequency. It is resonating in its natural mode of vibration with sound. Now, this gets even better. Yeah, if I go faster, what do you guess is going to happen? It's going to get even louder. Let's see. So this is one. You hear that? It's higher. What mode of vibration do you think that is? So the first one was the lowest one. That was mode number 1. The second one was mode number 2. And so all you're doing when you're swinging it faster is you're making the air move through it faster. And every time you hear that frequency go up, you're going up by a mode. Those wavelengths are decreasing, and when you have smaller wavelengths, you've got a higher frequency and a higher pitch. And that's what's happening. I don't know if I can get up to mode number 3 or not. This might get kind of dangerous. Let's see. Yeah. You can see.
How do you know it's not mode?
Because the first mode is automatically the lowest one you can get. And so I can't, like, this is no mode here. But eventually you get that one. That's mode number 1.
Can you keep building it?
Yeah, I can't really swing fast enough to get to mode number 4, I don't think.
So, like, can you try?
Yeah, I'll try. All right, we'll see how...
Do you want to stand under that?
Oh, gosh. I suppose... Yeah, I'll go over here. They'll give me some more space. Suppose I should put my mask on. All right. I think that was 3 again. Might just have to swing it. Nope. Not working. Wow, 5 minutes and this class is already down the tubes. Get it? Okay. So that's one example. I got a couple others for you here. My dad actually lives 100 miles north, and he goes to Shawano to get these special pop bottles. And the reason he does that is because when he was a kid, he worked as a mechanic, and they had a little pop machine there. And when they went out of business, he got the pop machine. So it's in their basement, and it takes these glass bottles. So if you want to hear some examples of resonance with sound, all you got to do, as Brooke was showing, is just blow right over the top.
Oh, yeah, I've done that before.
Yeah. That's your first mode of vibration. That's your fundamental frequency. So in order to get a higher mode, you just got to blow faster, same way that you got to swing the tube faster. If you have sensitive ears, you might want to cover them, because you really got to blow it really hard to try and get that second mode. It's tough to do. and I might pass out. So we'll leave it at that.
I might
Now,
pass out.
we're used to seeing these different modes with the slinky, where you're holding both ends. That would be an example of two fixed ends. How many ends are fixed, would you say, in this example?
One.
Just one. So you'd have a fixed end and an open end. And that's what we're going to talk about today. We're going to figure out exactly how to draw those and how to get wavelengths and things out of them. Now, what do you suppose is going to happen? I got another example right here. Same thing. What do you suppose happens if I fill this one with water? Is that going to cause the frequency and the pitch to get higher or lower? Let's see. I hope that one was pretty. That one was pretty. You guys were really confident in that, and everybody kind of agreed. Pretty unanimous. Let's hope that we get a lower pitch. Here we go. It's actually a little bit higher. And I'm going to, it's kind of hard to do. So remember this, as opposed to, so the second one was lower. As you increase the water level, your pitch goes up. Because as you decrease that length, you're decreasing the wavelength. And when you have a shorter wavelength, you have a higher frequency and you have a higher pitch. I got one more example to show you. I think you'll like this one. This is another one you've probably seen before.
That's the one I was about to ask about.
Yeah.
Wait, I was gonna ask that. Are you gonna do the?
Yes, I will.
Are you gonna do? Are you gonna like?
No, I'm not quite that good, but I can get one going here. So all you gotta do is just go around the top.
Get out.
Thank you.
Here you go.
Camera. There we go. All right, so here we go. Like a wine glass DJ. Who else wants to give it a try?
I've tried that before.
I'll try. I don't think I can. I've never been able to do it.
Really? Anybody want to give it a shot? Sure, come on up. If anyone can do it, Brooke can do it. So all you do, you just dip your finger in here, and then you want to try and keep it towards the middle part of your finger, and press down with a good amount of force, kind of like about that much. That's about as much as I'm pushing down. And make sure to hold the bottom like right there. Just try different pressures, and it might just eventually start happening.
Yep.
It's tough to do, but it's one of those things where once you do it once, you'll always be able to do it. Those are interesting noises. Try easing up a little bit on the pressure. Yeah, I did hear it a little bit. I heard it for just a second there.
You tried it.
Yeah, give it a shot. Give it a shot.
I feel like I don't.
Your music thing, I'm mine.
This is okay.
There it is. So maybe you needed to go a little bit faster around the rim.
Try it again. I
I can hear it trying.
Go faster.
That's as good as it's gonna get.
I got it a little bit.
That was good. Round of applause for the ladies. Anybody else want to give it a try? All right, come on up. Same thing, just dip your finger in there, and you want to push down with kind of a fair amount of pressure. When I push down, I'm going about like this, about that hard. And then hold it from the bottom.
Oh, my finger keeps slipping off.
Whoop. There it is.
If I could keep my finger on there.
That's okay.
Oh, I see that.
I should have moved this anyway. That's not your fault. So yeah, last call. Anyone else want to give it a try?
Let's do it.
Okay. I'll just do it one more time for the fun of it. But yeah, once you get the hang of it, it'll be like nothing. You'll be able to do this on each and every glass in your household or someone else's. So practice, practice, and eventually you can make music like that.
My finger just keeps sliding off.
Yeah, you just kind of got to get the feel of it. Because you got to get the pressure right, and you got to get the position right, and you got to get the speed right. Once you kind of figure out how it works, it'll be real easy for you. So this is an example of resonance. What's actually happening is this glass, as my finger and as your fingers were going across it, it's producing this sound. And of course, sound, as you heard from the interesting lady from the SciShow Kids yesterday, sound is produced when you have vibrations. So what's happening is this glass is actually vibrating back and forth very, very quickly, producing those vibrations, disturbing the air next to it, which disturbs the air next to it. Eventually, the air next to your ear is vibrating at that frequency, and that's why you hear it like that. If I put a straw in here while it was happening, you could actually see the straw bouncing around like that. And I'll show you a video in just a little while here of what this looks like in slow motion. So hold tight for that. So again, we're talking about resonance. We're talking about natural frequency. And I just want to make sure you're familiar with those two terms. Yeah?
Does it only work if there's water in it?
That's a good question. It should work without water in it. Yeah, it still works. Just got to have a wet finger. So when we're talking about resonance, we're talking about waves that are doing that resonant wave behavior just in general. And when we talk about natural frequency, that is a more specific type of resonance. It's the type of resonance where an object is resonating at a very particular frequency that it's designed to. You know, this glass, when I do that, is only resonating at one particular frequency. I can't make it go higher and lower based on what my finger's doing. It's only going to vibrate at the natural frequency of that glass. And that's based on several different things. I do want to tell you a little bit about some more things here with respect to overtones and harmonics and modes. And they're pretty straightforward. So if you could join me in the back of the classroom. Be back after these messages. This won't take too long, but I do need a volunteer. Val again? Yeah. Awesome. Thank you. Same as last time. We'll just go down to the floor here. So last time we talked about different modes. And we talked about how this is mode number 1. No surprise there. We talked about how this looks like that's mode number 3. So that would be the 3rd mode. And I could get up to the 4th mode, and I could get up to the 5th mode. And that's really cool, but there's a couple things about terminology that I want to make sure you're aware of as we go forward with these worksheets. So this is called the 1st mode. This is also known as the 1st harmonic. This is the 1st harmonic. Mode and harmonic mean the same thing. Now, if I get to mode number 2 like this, this is also the second harmonic. So mode and harmonic are the same thing. The other piece of terminology you have to be aware of is overtone. This is the first overtone. Overtone is basically whatever your harmonic or your mode is minus 1. So if this is our second harmonic, our second mode, this is our first overtone. Alright, what mode is this right here? I think this is number 4. I think I see 4 bubbles there. So if this is the 4th mode, what harmonic is it? Yeah, number 4, because harmonic and mode mean the same thing. Which overtone is this? 3, very good. If I go a little bit faster, looks like this is mode 1, 2, 3, 4, 5, 6. I think I see 6. If this is mode 6, what harmonic?
5.
Harmonic 6. And which overtone? 5, yeah. So harmonic and mode mean the same thing. Overtone is just 1 less than that. Alright, now thank you. You can let go. And that's all I wanted you to see from this. Let's head back.
Yeah, I like this one.
And we'll formalize this knowledge shortly here with the notes. And I'm going to get these passed out to you right now. Sort of. It's going to be due, I think, Monday next week. You're welcome. Mm-hmm. I've actually got 2 videos I want to show you, and because I'm recording this class, I'm going to put those off to the end. But for right now, let's go ahead and go through these notes together, and that way you should have a good idea on how to approach the homework. Wait for So as you can see, you're not actually taking notes today. I just handed them to you because it's one of those things where I don't go through any problems on it, so it doesn't really do you any good to work through it. It would just be a process of you writing down the same things I have. So I'm not really interested in wasting your time with that.
Very well.
The homework is rather long. The good news is that the entirety of tomorrow is dedicated to you guys working on it, so that I can be here to help you through it. You're welcome. The whole point of what we're doing today is, we've already done stuff like this for 2 fixed ends. Now, the whole purpose is to expand that knowledge to where we have 2 free ends and 1 open end, 1 free end. So I'm just going to quick explain the top half of the notes. This should take no time at all. When you have a fundamental frequency, that's the same thing as saying the first mode. And of course, the first mode is the same thing as the first harmonic. There is no overtone for your first mode. 2 times your fundamental frequency is equal to your second mode, also known as the second harmonic, first overtone. Third mode is the same thing as the third harmonic, second overtone, because it's just -1, and hopefully you can see the pattern there. The most important part about the top half of this is to remember this. Just like when we dealt with wavelengths with 2 fixed ends, this equation to calculate your wavelength does not change. It will always be that. So if you feel like circling that or putting a little star next to it or something, feel free to do so. down to the bottom. So, when we dealt with two fixed ends, we said that the amount of half waves present during resonance is equal to a wave. So, when we're talking about these modes represent how many waves you've got there. And for when you've got the two fixed ends, the first mode gave you half of a wave. Like this is an example of two fixed ends here. And you've got yourself half of a wavelength, half of a wave. And that was mode number 1 for two fixed ends. Now this is two free ends right here. This is what your first mode with two free ends is going to look like. Because the end of your waves are free to move up and down. So that would be mode number 1. And you can see we're going from a trough to a crest, and that means that you've got half of a wave here. Just like you've got half of a wave when you've got two fixed ends. That's where this 0.5 comes from. This is half of a wavelength. So in mode number 1, for two free ends, we've got 0.5 waves. Questions on that? Okay. And from there, you pretty much get the same thing that you got when we did this for two fixed ends. As you go up by one mode, the number of waves present always increases by half. So for mode number 2, we're going to have one full wave. And you can see that if I would just continue this picture. You've got two free ends, so that means when I continue it over, I would have to go until I get another free end. So it would go till you got something like this. This would be mode number 2. And you can see crest to crest, that is one full wavelength. That's why the second mode is one wave. Everybody on board? If I lost you, let me know. So then the third mode is 1.5 waves. If you want to draw the third mode, you continue this till you have another open end. That's mode number 3. So you can see we've got half of a wave, 1 wave, 1.5 waves. So that's where that comes from. Fourth mode would be the same. You just continue it again. And that's how you would continue to draw these modes as they get bigger when you've got two free ends. You just have to keep drawing the picture until you have another open end. Now, of the two, that's the easier to understand when you compare it with this example here, one free end and one fixed end. If you've got a fixed end, then you've got a node there. The waves are coming together. But if you have a free end, the waves are going apart at that place. So this right here would be your fundamental frequency, or an example of mode number 1 when you've got one free end and one fixed end. So this is mode number 1 when you've got a fixed end here and a free end over there. And you can see this is half of this right here. So if this is 0.5 waves, how many waves is that? 0.25, exactly. So that's where your 0.25 comes from. Now, once you get this figured out, everything after this continues the way it's always continued. Whether you're going up by one mode for this scenario, or this scenario, or this scenario, you're always increasing your waves by 1/2. Because if I increase this, and I draw it until I have another open end, now I've got 0.25 waves, and now I've got this shape. Well, remember, this shape is equal to half of a wave. So we've got 0.25 waves plus 0.5 waves, and that's where the 0.75 comes from. And again, you don't have to go through this in your mind every time you're figuring out the waves here. You just have to know that as you go up by modes, you increase your waves by 0.5 each and every time. But this is what mode number 2 would look like. Mode number 3, I would continue it to another open end. Mode number 4, I would continue it to another open end, and so on. That's how you would draw higher modes of a fixed end and a free end. Questions on that? I know this is a lot, and that's why I'm giving you all of tomorrow to work on that worksheet, so that way I can kind of help you through spots that give you trouble. But this is the idea. A lot of it is the same as the stuff we've already done. Okay, I'm going to show you those neat little videos then.